See, but in previous class in molarity we have seen uh, if they will give the number of moles, volume in liter, volume in ml, we are able to calculate molarity. Instead of number of moles, suppose they give the weight of solute and they give the volume of solution in liter or in ml, we are able to calculate the molarity. And a third part we did in the molarity beta, if the weight of the solute is given, but instead of giving the volume of the solution is in ml, they will give the mass of the solution. And once they will give the mass of the solution with the help of a density equal to mass by volume, we are able to find out the volume of solution, either it is in ml or liter, and then we can substitute that value in the molarity and we are able to calculate the molarity. But sometime in this molarity term mein, but sometime in this molarity terms mein, they can give us or they can ask us what is a molar solution. So these terms are there. But if it is a molar solution means indirectly they are talking about 1 molar. If they are saying it is a semi-molar solution means, but a semi-molar solution means it is a semi beta 1 by 2 molar. 1 by 2 molar is a semi-molar. It can be written as m by 2. Is it clear beta? Semi-molar means half. 1 by 2 molar, nothing but the m by 2 molar. Beta 1 by 2 is called as a 0. Sorry, by solving the 1 by 2 0.5, the molarity become a 0.5 molar. Then it is a semi after that if you see the decimolar, but if it is a decimolar solution then it is a m by 10, but m by 10 can be written as 1 by 10 molar. 1 by 10 molar can be written as zero point 0.1 molo, zero point 0.1 molar. So molar, semimolar, decimolar, then centimolar. If the solution is given as a centimolar solution, then it is a m by 100 centi. That means it is a 1 by 100 and it is 0.01 molar. So these are the few terms are there we have to remember. Amolar, semimolar, decimolar, centimolar. Please note down this one. Clear, Veda? One second. I want to give
Yes, sir.
question based on this point. But calculate the mass of NaOH present in 400 cubic centimeter of semimolar NaOH solution. See, beta, what is the given data that you first take out? Semi-molar is given. Semi means 1 by 2 molar. So molarity equal to 1 by 2 means 0.5 molar. But a volume of the solution is given as a 400 cubic centimeter. You know, 1 cc equal to 1 ml. Yeah, that is equal to 400 ml. Molarity they have given, volume they have given. They are asking to get the mass. So our formula, molarity equal to 1000 by volume is in ml. See with the molarity 0.5, weight we have to get it What is the gram molecular weight of NaOH? Yes, it is a 40. Weight by 40 into 1000 by volume of solution. What is the volume of solution given? 400 ml. 1, 2, 3. 1, 2, 3. Right? 4 into 4, 16 into 0.5. The weight is equal to 0.5 into 16. Right, beta? 5, 6, 30, 0, 3. 5, 1, 5, 6, 7, 8. It's correct? By 10.8 gram. 0.8 gram. So the weight of NaOH is equal to how many? That is 8 gram present in the 400 cubic centimeter of semi-molar NaOH solution. Right? Take a screenshot, beta. But after this one, calculation of molarity by knowing the centimolar, semi-molar, decimolar, and all. Now we'll see different uh, different type of the questions they will ask in the molarity. That one also we will see here. Called as a dilution law, beta. That will be called as a what? Dilution law. What is that? Listen here. In this dilution law, beta, in this dilution law, what is that? Initially, some solution we are having, whose molarity and volume we know, but when we added the water on it, adding a water called as a dilution. So remember, what is meant by dilution, beta? When we are pouring the water, we are adding the water, that will be called as a dilution. And due to that, it's a concentration changes. So what is the concentration? That is a new molarity. By adding some water, total volume we will get here. So this M1V1 is a initial and M2V2 is the final. But I want to explain you this one by putting a small diagram point of view. Suppose I am having a beaker. In this beaker, I am having hydrochloric acid HCl. Right? Initially, its molarity is 0.5 molar, and its volume is, suppose let us say 100 ml is the volume. This is the initial volume, initial molarity. What we are doing, beta? Just we are adding the water on it. When we are pouring the water on it, obviously volume will increase. How much? Chalo, I don't know. I want to say yes. We are pouring here. Uh, but we are pouring here 100 ml of water. But by pouring the 100 ml of water, now you can see the beaker is same, but initially volume which is a 100, now it reaches to 200. So in this one, what we have, but our total volume is equal to now 200 ml. Why? Because initially 100 ml of solution was there, and now we are pouring again 100 ml of water on it. So total volume become what? 200 ml. In this 200 ml of this solution, what is the concentration of this HCl solution? Now, after pouring the water, what is the concentration of this HCl solution? So how to find out beta this concentration of this HCl solution after adding water? Addition of water means we are diluting it, and the law called as the word dilution law. Beta initial concentration will apply. What is the initial concentration? We have 0.5. What is the initial volume? We have 100 ml. What is the M2 we have? We have to find out. What is the V2 we have? Beta total volume. This V2 is indicate nothing but the it is what? Total volume. Total means initially beta 100 and again 100 ml of water we are adding. So total volume become what? 200 ml. Now get the molarity formula. Sir, M1V1 equal to M2V2. That means M2 equal to M1 V1 by V2. See beta, M2 will be here. V2 come at the denominator. What is the M1 value we have? 0.5. V1 value 100. What is the V2 value beta? That is 200. 1, 2, 1, 2. Right? It become a zero point 0.5 by 2. 0.5 by 2 can be written as 5 by 10 into 1 by 2. How about 0.5 become 5 by 2 into 1 by 2. 2 ones are 2, 2.5s are, and 2.5 by 10, if you want to write, it should be 0.25, 0.25 molar. Is it clear, beta? What is the concentration of these HCl solution after adding 100 ml of water of 1 molar? Sorry, after adding 100 ml of water in 0.5 molar, the concentration of HCl now it become 0.25. Initially 0.5, now it becomes 0.25. Concentration decreases by adding water molecule called as a dilution law. Right? Take a screenshot, beta. One more example I want to give for you. You try it. Now, one more question I will give based on the same topic. Please try it. What is that? Calculate the molarity of NaOH solution. Calculate the molarity of NaOH solution, which is NaOH solution of 0.2 molar, 0.2 molar, 200 ml is diluted with. Calculate the molarity of NaOH solution of 0.2 molar, 200 ml is diluted with 200 ml of water. So, beta, obviously, initial concentration they gave, and they already informed that this much ml of water was added over it. And we know addition of water is nothing but a dilution law. And they are asking to get the new concentration of NaOH. So, make it data beta what they give. Initial concentration 0.2 molar. Beta volume is in ml, 200 ml. But another concentration we have to find out. What is the second volume V2? Beta V2 is equal to total volume you have to take. What is the total volume, beta? Initial volume, that is V1, plus volume of water to be added, VH2O, to be added. That means what is the V2 you should write? So 200 is the initial volume and volume of water is added is also 200. Total it become 400. Our formula, dilution law wala, M1 V1 equal to M2 V2. But what you want? You want V2. That should be equal to M1 V1 by V. Sorry, M1 V1 by M2. You want M2 na? So M2 is equal to M1 V1 by V2. What is the M1? 0.2. What is the V1? 200. What is the V2? 400. 0, 0, 0, 0. Two ones are, two twos are, 2.1s are. Beta concentration is 0.1 molar. So we can say the new concentration of the solution is 0.1 molar. Right, beta? Chalo, take a screenshot.
Done, sir.
But now one question I want to give for you. Everything is same. Just values I am going to change here, right? Values I am going to change here. Calculate the molarity of HCl solution of 0.1 molar, which is a 200 ml, and it is diluted with a diluted with a 100 ml of water. 100 means 400 ml of water. So beta volume of the water 400 ml. HCl whose initial concentration is 0.1 at volume is what? 200 ml. Get the molarity of the solution when it is diluted with the 400 ml of water. Chalo, try it beta. And now we'll see molarity of HCl solution means initially we'll see what the M1 they give. Sir, it is a 0.1 molar. But a volume V1 is, it is 200 ml diluted with a 400 ml of water. So M2 anyhow we have to find out. And it is a V2 is total volume nothing but a V1 plus volume of water to be added. That is 200 plus 400. It becomes 600 ml is a V2 beta. That means according to dilution law, M1 V1 is equal to M2 V2. M1 is 0.1, V1 is 200. Right beta? By V2 is 600. That gives rise to directly M2. 1 2 1 2. 2 ones are 2 threes are. So I should say molarity M2 it should be zero point 0.1 by 3 can be written as 1 by 10 into 1 by 3. Zero point 0.1 can be written as 1 by 10 beta. Beta 1 by 3 की value once you check it 0.1 by 3 0.33 by 10. That means it becomes a 0.033 is the molarity of the HCl solution when it is diluted with 400 ml of water. Right? Very good, beta. Take a screenshot.
Done, sir.
Chalo. But after this dilution law wala concept, we will go. Few more questions are there, and that question is nothing but getting the molarity or the concentration of the resulting solution. So let me explain you how to go with the resulting solution concept wala. I'll teach you 1 second. Example. But now these are the molarities are there. Means let us say I am having one of the beaker, and but in this beaker I am we have taken the acid. HCl is acid. But its concentration is zero point 0.1 molar and its volume is 100 ml. Another beaker, it also contain the acid only. See here. But it also contain what? Acid. But this acid concentration is different from this one. I should say M2. It is a zero point 0.2 molar. 0 0.1 molar, 0 0.2 molar. Volume 100. Your wish. Whatever the volume you want to take, you take beta. I want to take 200 ml. Now what they do beta, if both the acids, this beaker and this beaker acid, they will keep an on, they are going to keep on the third beaker. Now they will ask, what is the total volume of this solution? Sir, obviously V1 plus V2. Our V1 is 100 and V2 is what? 200. 100 plus 200 become what beta? It become a 300 ml. It's a total volume. Total volume. But what is the nature of this solution? Yes, sir. But the nature of solution is what? Acidic. Why? Because HCl is the acid. HCl is the acid. If both are acid, the resultant solution become acidic in nature. Now they will ask, sir, what is the molarity of resultant solution? What is the molarity of resultant solution? But to calculate the molarity of resultant solution, this is the method is there. I'll show you 1 second. Molarity of resultant solution equal to M1 V1 plus M2 V2 by V1 plus V2. Beta, what is the M1 we have? 0.1. What is the V1 we have? Check it, beta. 100 plus what is the M2? 0.2. Beta, what is the V2? 200 into by what is the V1? 100. What is the V2? V2? 200. And now you solve it. 0.1 into 100, 1 by 10, 10. 0.2 into 200, 2 by 10, 0, 0 cancel. 20 into 2, 40. By 200 plus 100, it becomes 300. 40 plus 10, 50 by 300. But 5 by 30, 5 ones are 5 6 are. So molarity of resulting solution is equal to 1 by 6 molar. Or if you want to solve in the decimal, it is equal to 0.10. 6 ones are 6. 10 minus 6, 4. 40. 6 6 are 36. 6 6 are 36. So, but a molarity of the resulting solution become what? 0.166 molar. Is it clear? Right? Take a screenshot, beta. Now, beta, one question I will give based on this topic. Calculate the molarity of resulting solutions. How to calculate the molarity of resulting solution? One question I will give. Please you try it and let me know the answer of this one, right? So topic name is beta molarity of resulting solutions here. Molarity of resulting solution. Now, question is here beta. 0.2 molar 100 ml solution of nitric acid HNO3. 0.2 molar 100 ml solution of nitric acid is diluted with 100 ml is diluted with 100 ml of water. So nitric acid is there, but the initial concentration 0.2 molar 100 ml is there, and they are asking to get the now that solution is diluted with 100 ml of water. Calculate the molarity of resultant solution. Calculate the molarity of what? Resultant solution. Chalo. Please beta, you try it once. Let me know the answer. Then I will do. Right? Chalo, do it fast. See beta, this is a question which is I have given. It is a question based on the dilution law, not the molarity of resulting solution. It is a question based on dilution law. Because already you are having 0.2 molar 100 ml diluted with 100 ml of water. What is the molarity of resultant solution and what is the molarity of that dilute solution? So I should say instead of resultant solution, what is a molarity of diluted solution? And here the topic which one we wrote, that is different what we are doing, and the question which one I gave, that is different. So it is nothing but a confusion to make the confusion for the children. So that either we have to use the dilution law or we have to use the molarity of the resultant solution. So it is a dilution
So
law.
formula
HNO3 beta,
used for
initial concentration given 0.2 molar, volume V1 is given 100 ml. We are diluting it with the water. So beta volume of water is how much? 100 ml. So I should get the molarity of that dilute solution. So what is a V2 beta? V2 is V1 plus volume of water to be added. Beta V1 is what? 100. Volume of water to be added 100. Total V2 become a 200 ml. Our dilution law. M1 V1 equal to M2 V2. Beta M1 is 0.2, V1 is 100, M2 find out. Beta V2 is 200, 1 2 1 2. Zero point 0.2 by 2 equal to zero point 0.1. Hence we can say molarity of resulting solution is what? 0.1 molar. See, dilution law we did, molarity of resulting solution we did, and I wrote the heading of that one. I give the question of dilution law. It is a way to confuse the children because we should be very much attentive what they given in the question and what they are asking to find out. Is it clear? Chalo, please note down.
Sir,
I'll give one more
actually,
question for you.
sir,
Now, beta, I will give the question for that one. Which one? Calculate the molarity of the resulting solution wala concept we did na. From that one, I will give questions. Listen here. Right. 0.2 molar 100 ml NaOH. 0.2 molar 100 ml NaOH is mixed with 0.4 molar 200 ml of NaOH. This is a NaOH means basic solution mixed with another NaOH that is also basic solution. So both the NaOH are mixed together, is mixed together. Then calculate the molarity of resultant NaOH solution. Obviously, beta, both are basic solution. The resultant solution is a basic in nature, and you have to calculate molarity of resultant solution. Please do it, beta. This one, get the answer. Try it, beta. Try it. 1/3, right, beta? See here, they give molarity of resulting solution is equal to M1 V1 plus M2 V2 by V1 plus V2. M1 V1 plus M2 V2 by V1 plus V2. But what is the M1 we can consider here? Sir, M1 is zero point 0.2 molar, V1 is 100 ml, M2 is zero point 0.4 molar, and V2 is 200 ml. Substitute here. Molarity of resultant solution M1 is zero point 0.2 into 100, zero point 0.4 into 200. Total V1 plus V2, 100 plus 200. 0.2 into 100, 2 by 10, 0 cancel, 2 into 10, 20. Zero point 4, 4 by 10, 0, 0. 4 into 2, 8, 80. 2 plus 1, 300. 80 plus 20, 100. Very good, very good, very good. 1/3 molar is a molarity of solution. If you want to take in the decimal form, it is become 0.10. 3 3s are 9, 3s are 9.33 molar is a molarity of resulting solution. Very good, beta. Very good. But one more question. One more question we will do. Are you able to see here? 0.2 molar. Right, beta. 0.2 molar, 100 ml HCl solution, 100 ml HCl solution is mixed with, now see beta, this is acid. Same, we are talking about the same solution. So now it is mixed with 0.3 molar, 300 ml mixed with 0.3 molar, 300 ml HCl solution. See HCl, HCl, 0.200, 0.3, 300. They are mixed together. So 0.2 molar 100 ml mixed with 0.3 molar 300 ml HCl solution. Calculate the molarity of resultant solution. Right, beta. This one also you tried. If previous one you got, now definitely this one also you will get it. Right. 0.025. We'll check it, beta, here. Sir, M1 0.2 molar. Beta, V1 100 ml. M2 0.3 molar. V2 300 ml. Correct? Then molarity of resultant solution M1 V1 plus M2 V2 by V1 plus V2. 0.2 of 100, 0.3 of 300, 100 plus 300. 2 by 10, 20. 3 by 10, 90. Hana beta, 0, 0 cancel. 3 into 3, 9, 0. 3 plus 1, 400. 9, 10, 11. 9, 10, 11. 110. 400. It is 11 by 40 molar. 11 by 40 means if you take 1 by 4, 0.25, it is approximately 0.25 becomes 0.23824, somewhere approximately value. It's not exactly approximately value I got. But 11 by 40 molar, if you take as a 10 by 40, 0, 0 cancel, 1 by 4, 0.25. But as the numerator value increases, right beta, the value of this one, acha, 25 become a 26 possible. So 0.26 molar is the answer. Very good, beta. Very good. It's correct. Now, but after this molarity, all the concept we clear, I will go for the second concentration term, and that will be called as a molality. Very important, beta. Molarity, molality, mole fraction, and last we have to check with the normality. Right? Last, not now. So now we'll see the second part that will be called as a molality of the solution. MOLALITY. But it is denoted as a small m. Right? Definition. It can be defined as, but it can be defined as the number of moles of solute Number of moles of a solute. Is it clear, beta? Number of moles of a solute present in 1 kg of solvent. Means molality denoted as a small m, that is a n by W is in the kg. Yes, that means molality equal to number of moles by, if the weight of solvent is given in gram, it should be multiplied with 1,000. Third one, but a number of moles means we know weight by gram molecular weight into 1 by weight of solvent is in the kg. And last में molality equal to weight by gram molecular weight into 1000 by weight of solvent in gram. See, beta, these are the formulas are there for molality. But remember, again and again, I will inform you. Beta, N indicate number of moles of solute. Sir, what is the number of moles of solute? Beta, it is a weight of solute by gram molecular weight of solute. It is a weight of solute by gram molecular weight. See, in place of these N, we substituted weight by gram molecular weight into 1 by W. But here also weight by gram molecular weight into 1000 by W in gram. Means what is this W? But a W indicate it is a weight of solvent. But it is maybe in kg or it is maybe in gram. It depends. If it is in gram, multiply with 1000 here. 1000 by W, weight of the solvent in gram. But if it is in kg, 1 by weight of solvent is in kg. Right? Chalo. Please note down up to here. We'll do the numerical.
Done, sir.
But now we will do some questions based on this molality term. But before going to do more questions and all, I want to tell you, molality is the concentration is, that is temperature independent. But these are the temperature independent, means does not depend on the temperature. By changing the temperature, either by increasing or by decreasing, value of molality never changes. Molality, temperature independent. Second one, the units of molality, if we want to say, then it is a mole per kg. Can be written as mole per kg. This is a unit of molality. But a question is given now. See here, I will give one question for this molality ke liye. Calculate the molality of, calculate the molality of 20 gram of NaOH is present in 100 gram of water. See, beta, molality they are asking to find out. Molality they are asking to find out. Weight of solute is there. Beta, this is a weight of solvent. You know, NaOH is a solute, means water is a solvent. Solute plus solvent together will make the solution. Yes, molality equal to weight of solute by gram molecular weight of solute. But a solvent weight is given in gram. Gram means 1000 by weight of solvent in gram. 1000 by weight of solvent in gram. Now you know what is the weight of solute. So you can say, sir, weight of solute is 20 gram. But what is the gram molecular weight of the solute? That is a NaOH. I ask you to by heart, that is a 40 gram per mole. हाँ बेटा 40 gram mole inverse is a gram molecular weight of NaOH. What is the weight of solvent, sir? Yes, sir. Weight of solvent. Solvent is the water, and solvent weight they give 100 gram. Right? Now substitute all the values here. We'll get molality. Weight of solute 20 gram. Gram molecular weight of solute 40 gram per mole into 1000 by weight of solvent in gram. 1 2 1 2 1 1. But of 4 5s are molality equal to 5 molal. But a 5 molal can be written as 5 mole per kg. Is it clear, beta? 5 mole per kg is the unit of the molality. Is the unit of the molality. Right? Chalo, note down. Now, beta, in this molality way, we'll try to see some different kind of the questions are given. Different kind means some density related problems are there. Because this is a one model is enough to understand the molality. It's a very simple. But a weight of solute should be there. Weight of solvent should be in the gram. That is enough. Weight of solute and weight of solvent. It is in the gram. Right? So if we know the weight of solute, if we know the weight of solvent, we are able to do the question based on the molality. One more question I want to give for you. But if 34 gram of ammonia is dissolved in ammonia NH3 gram molecular weight 17, and I have taken 34 gram of ammonia. It is dissolved in 100 ml of solution. Density of solution is given. Let us say the value is given as a 1.2 gram per ml. Yeah, but if it is a 34 gram of ammonia dissolved in 100 ml of solution, density of solution is 1.2 gram per ml. Calculate molality of solution. Now think that beta. They have given volume of solution is in the ml and they are asking us to get the molality. Our formula of molality, you know, what is that? Molality equal to weight of solute by gram molecular weight of solute into 1000 by weight of solvent is in the gram. See beta, weight of solute is there with you. 34 gram. Do you know gram molecular weight of ammonia? Yes, sir. Gram molecular weight of ammonia is 17 gram per mole. That is the value we know. Substitute the value into 1000. Yes. But these things I want weight of the solvent in gram. But here they give volume of solution is in the ml. Volume of solution is in the ml is there. Density of solution is there. We can get the mass of the solution. How? Let's say mass of solvent. This is mass of solvent. How? See here. Density of solution equal to mass of solution by volume of solution. But a mass of solution equal to density of solution into volume of solution. Density of solution 1.2 gram per ml. Volume of solution 100 ml. Ml get cancelled. Beta 1.2 into 100 by 10 cancel. It become 120 gram is the mass of solution. What do you want, beta? You want mass of the solvent. Now we know again, sir, mass of solution must be equal to mass of solute plus mass of solvent. Beta mass of solution 120 gram, mass of solute 34 gram plus mass of solvent. Then mass of solvent is equal to 120 gram minus 34. We'll get the mass of solvent, right? 10 minus 4, it becomes 6. Then it become what? 1. 1 become what? Again 11, 3, 8, 9, 10, 11, 86. Right, beta? 86 gram is the mass of solvent I got. Substitute this mass of solvent value in our formula by substituting, calculate it, you'll get the molality of the solution because it become 2s are beta. 2, 4s are 8, 3s are, it become a 1000 by 43 molal. And if you want to solve approximate, I don't know, but approximate, if you want to do 0, 0 cancel, 425s are, right beta? 425s are. So by increasing this one, we'll get 24.67 molal is the molality of the solution. Did you understand? They gave volume of the solution is in the ml. They are asking to get the molality, and we know beta molality may we want this one is what? So this is the weight of solvent I want. What we want beta? We want weight of the solvent. See beta, mass of the solvent is weight of the solvent. How we are getting? Mass of solution equal to mass of solute plus mass of solvent. Mass of solvent equal to solution minus solute. Solution की mass we are getting from here. Density equal to mass by volume. So mass is equal to density into volume. We got mass of solution minus mass of solute. We'll get mass of solvent. That is the weight of solvent. Substitute here. Solid. We'll get the molality of solution. Understood? Take a screenshot of this one.